Hello everyone, in this video I'll be explaining on the topic phase contrast microscope. Coming first to the principle, here when rays of light are passed through an object, they emerge in different phases depending on the difference of the refractive indices between the object and its surrounding medium. A special optical system called a special condenser and objective lens converts difference in phase into difference in intensity of light, producing light and dark contrast in the image. The working principle of this phase contrast microscope includes partially coherent illumination produced by the tungsten halogen is directed through a collector lens and focused on a specialized annulus, that is a label condenser annulus, positioned in the substage condenser front focal plane. Wavefront passing through the annulus illuminate the specimen and either pass through undeviated or are diffracted or retarded in phase by structures and phase gradients present in the specimen. Undeviated and diffracted light collected by the objective is segregated at the rear focal plane by a phase plate and focused at the intermediate image plane to form the final phase contrast image observed in the eyepieces. Coming to the parts and components of phase contrast microscope, this phase contrast microscopy is basically a specially designed light microscope with all the basic parts, in addition to which an annular phase plate and annular diaphragm are fitted. Coming first to the annular diaphragm, it is situated below the condenser. It is made up of a circular disc having a circular annular groove. The light rays are allowed to pass through the annular groove. Through the annular groove of the annular diaphragm, the light rays fall on the specimen or object to be studied. At the back focal plane of the objective develops an image. The annular phase plate is placed at this back focal plane. Next is the phase plate. It is either a negative phase plate having a thick circular area or a positive phase plate having a thin circular groove. This thick or thin area in the phase plate is called the conjugate area. The phase plate is a transparent disc. With the help of the annular diaphragm and the phase plate, the phase contrast is obtained in this microscope. This is obtained by separating the direct rays from the diffracted rays. The direct light rays pass through the annular groove, whereas the diffracted light rays pass through the region outside the groove. Depending upon the different refractive indices of different cell components, the object to be studied shows a different degree of contrast in this microscope. This phase contrast microscope is an optical microscope which is used in the lab for diagnosis. This phase contrast microscopy is an optical microscopy technique that converts phase shift in light passing through a transparent specimen to brightness changes in the image. Phase shifts themselves are invisible but become visible when shown as brightness variation. It was first described in 1934 by Dutch physicist Frits Zernike. Phase contrast microscopy improves the contrast and makes evident the internal structures of cells which differ in thickness or refractive index. The different parts of a cell and its surrounding medium have got different refractive indices. Unstained living cells absorb practically no light. Poor light absorption results in extremely small differences in the intensity distribution in the image. This makes the cell barely or not at all visible in a bright field microscope. A light microscope can be converted into a phase contrast microscope by using a special condenser and objective lens.